Hello everyone and welcome to another Math Tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 4 Permutations and Combinations Long Question Example 3. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, in this video I'm going to discuss two questions. Okay, you are looking at the first question. So once I done solving with this question, I'm going to proceed with the question number 2. Okay, for now let me read the question number 1 first. Calculate the number of 6-digit even numbers greater than 800,000 that can be formed from the digits 3, 4, 5, 6, 7 and 8 without repetitions. Okay, so this is the question 1. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question 1. Okay, to start off, the first step on what we need to do in order to solve this question, we need to identify the condition. Okay, in this case, the question asks for 6 digits even number and it must be greater than 800,000. Okay, so that is our condition asked by the question. So we already know the condition. So once we know the condition, the next step what we can do is we can straight find the arrangement. Okay, but before find the arrangement, let me write all the numbers given by the question over here, so it will be useful for our reference, guys. Okay, so the number given by the question is 3, 4, 5, 6, 7, okay, and then 8. So for the next step, what I'm going to do is I'm going to draw a 6 block. Okay, that 6 block representing 6-digit numbers that we are going to form. Okay, based on several cases. Okay, so please wait, guys. Okay, so this is the 6 block that we have drawn. Okay, so let us begin our case 1 from here itself. Okay, so in general, since we are need to form a number greater than 800,000, so your first digit, it can only have one possible number, which is number 8. Okay, you cannot have numbers less than 8. For instance, 3, 4, 5, 6 and 7. Okay, if you replace either one of the numbers over the first digit here, it will give you numbers which is less than 800,000. So I hope you understand the reason behind this. Okay, so you can only have one outcome over here. Okay, so this is for the first digit. Okay, and then the question also asks for an even number. Okay, even number means a number which can be divided by 2. Okay, for instance 2, 4, 6, 8 towards the last digit. Okay, in this case, since you've already fixed your 8 in the first digit, okay, you can only have 2 possibilities towards your last digit. Okay, where you can only have either number 4 or number 6. Okay, since we need to fulfill the condition that the number should be greater than 8,000 and the same time it should be an even number. So that's why, guys, I am proposing these possibilities to you. Okay, so the last digit you can have 2 numbers. Okay, whereas for the first digit you can only have one possible number, which is number 8. Okay, the rest you can permutate within these 4 digits respectively. Okay, for this case 1, I'm going to start with number 4 and then continue with the case 2. I'm going to continue where your number at the last digit will be 6. Okay, so from here, so this is our case 1. Okay, let me underline this. Okay guys, I know this chapter is a bit tricky, but please follow up with me. Okay, so for example, you already fixed your number 8 in the first digit. Okay, and now you left with 2 even numbers. Okay, but then you decided that, okay, now I'm going to place number 4 over here. for my first case. Okay, if you place number 4 over here, you can only have one possible number. Okay, you have already placed two numbers in the first digit and the last digit respectively. Okay, over here, so you still have 4 more numbers. Okay, these 4 more numbers where you can place your number 3, number 5, number 6 and number 7. Okay, you can permutate either the 4 numbers over here. Okay, so you can have here 4 factorial. Okay, so this is your case 1. So from here, from the case 1, so to calculate it, so what you do, the 1 you times it 4 factorial and then you times it 1 again. So 1 times with 4 factorial and then you times with 1. Okay, you calculate this, you should get your case 1 is equals to 24. Okay, this case 1 is where your even number equals to 4. Okay, this is your case 1. Okay, let us proceed to the case 2, where your even number equals to 6. Okay, let me underline this. Okay, we're going to use this similar block, so let me just copy paste this. Okay, so the only difference over here is, instead of using 4 here, we're going to replace with 6. Okay, so for the second case, you place your 8 in the first block and then 6 in the last block. So the remaining number 3, number 4, number 5 and number 7 will be permutated in the digit 2, digit 3, digit 4, digit 5 respectively. Okay, so I hope you understand, guys, the concept behind this. So from here, let us calculate them. So the case 2 will be similar to case 1. So the 1 you times with 4 factorial and then you times with 1 over here. So 1 times with 4 factorial, okay, and then you times with 1. So you calculate this, you should get 24. Okay, but this is not the final answer, guys. Okay, the final answer should be case 1 you plus with case 2. So in this case will be equals to 24 plus with 24. Okay, so let me write here properly, guys. Okay, so your final step will be equals to case 1, okay, and then you plus with case 2. So from here equals to 24 plus with 24. So from here you should get your final answer is 48. So you can have 48 arrangements in the condition where you should have 6 digits even number greater than 800,000. Okay, so let me underline the solution for the first question. Okay, so I hope you understand the working that I've shown for you for the question 1. Okay, let me scroll this down, okay, and leave it over here. So let me proceed my discussion for the question 2 now. Let me read the question 2 now. How many 4-digit numbers less than 6,000 can be formed from the prime numbers from 1 to 10 without repetitions? So this is the question 2. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Okay, in order to solve this question, the first step on what we need to do is we need to identify the prime numbers from 1 to 10 itself. Okay, for that we need to know the meaning behind the prime numbers. Okay, prime numbers are the numbers which can only be divided by itself and 1. Okay, so let us write the working over here. Okay, so this is our first step. So in this case, from 1 to 10, you can have a prime number of 2, okay, and then 3, okay, followed by 5, okay, and then 7. Okay, you can only have 4 prime numbers, okay, within 1 to 10. So this is our first step. Okay, so once we identify the step 1, okay, let us proceed to the step 2, where we need to identify the conditions. Okay, let me write the working here. Okay, so the conditions mentioned by the question is 4-digit number okay, where it should be less than 6,000. Okay, so this is the condition asked by the question. Okay, so this is our step 2. Okay, once we identify the condition, so let us proceed to step 3, where we are required to find the arrangement. Okay, so let me draw the 4 blocks over here, which are representing the 4-digit numbers. So please wait, guys. Okay, so this is the 4 blocks which representing the 4-digit numbers. Okay, so since we are required to form a 4-digit number which is less than 6,000, okay, so that means that in your first block you should form a number less than 6. Okay, in this case, numbers which is less than 6 are 2, 3 and 5. Okay, you cannot place number 7 over here. If you place number 7 over here, it will be more than 6,000. Okay, in this case, so you can only have 3 numbers as the possibility. Okay, so and then the remaining number you can permutate with 3 factorial. Okay, so this type of question I have discussed in the earlier of the question, guys, which is question 1, where I break down into case 1 and case 2. Okay, you can do that if you want, but in this case it will be tedious. Okay, so what I do in this case is, so since I know case 1, case 2 and case 3, they have the similar pattern of calculation. So from here, whenever you choose a number over here, you can only have one outcome at a particular case. So 1, okay, and then you times with 3 factorial. Okay, and then you should times with 3 cases, since you have 2, 3 and 5, so which representing 3 outcomes, so you should times with 3 over here. Okay, to make the working faster. Okay, this one is way faster than the earlier. So from here you calculate this, you should get your final answer is 18. So from here you have 18 possible arrangements where you have 4 digits number less than 6,000. Okay, so this is your final answer, guys. Okay, let me underline the question, the solution for question 2. So that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Any comments, questions or feedback, please feel free to put down in the comment section, guys. Thank you everyone for your support, and I'll see you in the next video.